All right, so today what we're going to do is expand on what you learned in the first block this week. We're going to kind of sharpen that axe a little bit more, and instead of talking about parallelograms, we're going to sharpen the edge a little bit more and talk about rectangles. So rectangles are a type of parallelogram. So all rectangles are parallelograms. So that means all of the properties that we learned already will also work with a rectangle. So think about what those properties are. Opposite sides are congruent to each other. Here's a nice little visual, right? The left side has to be congruent to the right side, because in a parallelogram, the top is parallel to the bottom and the left is parallel to the right. In addition to opposite sides congruent and parallel, opposite angles are also going to be congruent to each other. And you can see that here nicely with this little simulation. And then finally, in addition to the opposite angles being congruent, consecutive angles, same side interior, are going to be supplementary to each other. So the blue and the pink angles are going to be supplementary, meaning they add up to 180. So because it happens in a parallelogram, it's also going to happen in a rectangle. And then finally, careful, diagonals. This is the one that everybody messes up. Diagonals are going to bisect each other. So let me kind of make this an obvious parallelogram here. Yeah, that's good right there. Perfect. Yeah, right about there. Beautiful. So the red line folds over and the blue line folds over. And notice the blue line is obviously longer than the red line. That's not a property of parallelograms, but the blue line is being cut in half, and so is the red line. So diagonals bisect each other. That is a property of parallelograms. So if you're a rectangle, you get those 5 properties. But you get 2 more for free. So what I'm going to do here is this obviously isn't a rectangle. Let me make this thing a rectangle. So if you look here, the blue line is obviously longer than the red line. And then if I drag this over, now the red line is obviously longer than the blue line. But what if I kind of settle this thing back and forth, and it kind of blue line longer, red line longer, blue line. And it kind of settles back and forth until the diagonals are congruent to each other. That should look familiar. This is your rectangle. When diagonals are congruent to each other, meaning that all 1, 2, 3, 4 of these segments are congruent to each other, you're going to make a rectangle. And then obviously, not only are the diagonals congruent to each other, that's the first new rule, the angles are going to be 90 degrees. So this is a great little simulation here, and it's a great way to see it. Here the blue line's longer, here the red line's longer. If I want to make this thing a rectangle, straighten out your sides, make an angle 90 degrees. That makes the diagonals congruent to each other. So if you look here, this will always be a rectangle. The simulation makes the rectangle happen. If you look, I measured out all of the diagonals here. So from A to E and E to C, 4.08, they're all 4.08. So you have a bunch of isosceles triangles versus the triangles before in parallelograms were not isosceles. Lastly, notice the angles are all 90 degrees. In a rectangle, all the angles are congruent to each other. And because there's 360 degrees inside of a rectangle or inside of any quadrilateral, if they're all congruent, 360 divided by 4 is 90. So your 2 new rules. Rule number 1, we'll call them properties. Property number 1, diagonals bisect each other. Property number 2, all the angles inside of a rectangle are 90 degrees or congruent to each other. All right, so we're going to practice this a little bit.